Alright, so what we're looking at today is a couple of applications of vectors, and particularly what was in your homework about the unit vector and then getting vectors to have a particular magnitude. We're going to address here in a slightly different context. Okay, first of all, I want to make sure you guys remember what direction angles are for, because what we're going to look at relies on us having an angle that is a direction angle. Okay, does anyone remember what we said those angles, or how we said those angles were measured?
Clockwise from that way.
Okay, so from here, counterclockwise, also known as standard position. Okay, coterminal is two that have the same standard position, but yeah, we have this angle starting with one side on the positive x-axis and rotating counterclockwise. Now, as you guys have seen, when we've done various types of problems of various applications, we haven't always had angles drawn like this. So one aspect of this section is going to be you taking a problem where you're given an angle and kind of translating that angle into an angle in standard position. So we'll look at doing that a little bit here as we move forward. Okay? But what we're trying to do here is we're trying to find a vector that has a certain magnitude. Okay? So we're saying x is the direction angle of a vector, and that notation there is the notation for magnitude. Okay? We want to get a vector v that is at this angle x with this magnitude. Right? And if you think about it, this is actually somewhat true to life. A lot of the times we know what the bearing is, or we know what the heading is, or we know the angle that we're moving at, and we know the actual velocity or the actual force or whatever. And the challenge is to get the components then. Alright, so we're finding a vector, we're finding really, you could put in here a component vector for a given situation. Now, if you recall when we were looking at the homework, when we wanted a vector to have a certain magnitude, what did we do to it first?
Multiply by the reciprocal. If you want it to be 1.
Okay, we got its magnitude equal to 1. Now, I want you to think, before we worry about getting the magnitude we want, I want you to think about that. If we have a unit vector, and it's rotated at this angle, okay, then it's going to be somewhere, you know, along this, right?
Yep.
So what do you think we can use?
Unit circle.
The unit circle. Okay?
Unit circle is
Now keep thinking with me, because if you guys understand this, the formula here is a real piece of cake. Okay? On the unit circle, a point had what coordinates? If x was the angle,
X is cosine.
cosine of x, sine of x. So guess what? If we want the specific direction, then we're going to use cosine of that angle and sine of that angle as the unit vector components. Then we simply need to do what with our magnitude?
Multiply by the.
Yeah, multiply it by the magnitude that we want, okay? So, there's our formula. There's our formula right there. Our vector v is that magnitude of v that we were asked for, or that we wanted, the magnitude of v times the vector with those components. Now, notice this is in the unit vector form with the I and J. It could also be written as just cosine of x, sine of x. Okay, and obviously you don't have to use x for your angle. I think your book uses theta, but I couldn't type the theta, so I used x. All right,
I'm sure there's a way
So-
to get
there is, but it's a pain to find.
yeah.
All right, so does that make sense? Do you understand where that comes from?
Yes.
The unit vector comes from the unit circle, and then we simply multiply it by the magnitude that we want it to be. Okay. So,
But it doesn't have to be a point on the unit circle, does it?
well, that's the thing. When you do this, oh, I get what you're
You
saying.
know,
It
like
does,
not
the
like-
angle does not have to be one of the angles that we learned from the
Okay.
unit circle, but this is derived from the unit circle. Yeah, I mean, some of the problems we have, you might have 120 degrees or 300 degrees, something that was on our unit circle, but you could use the same process for an angle of 28 degrees. You just have to use your calculator to find the values. So let's take a look at a sample problem here.
Excuse me.
We're going to find the component form of a vector when we have an airplane. Now, notice here we're not talking about north, south, east, and west, because here we have this airplane that's flying downward. Okay? It says it's descending at a speed of 100 miles per hour. That is the magnitude of that velocity vector that we're trying to find. Okay?
Falling out the sky.
And it says that it's going at an angle of 30 degrees below the horizontal. So this angle right here is 30 degrees. Okay? Yeah, this is not a realistic problem, because if you're flying a jetliner at only 100 miles an hour, you'd be falling out of the sky. Alright, so,
It wouldn't be full.
and you would never go down at 30 degrees or else your passengers would be very upset.
Yeah.
Okay? In fact, I think
You don't even.
I think a commercial airliner, when they land, they're only going at like something like 8 degrees or something.
It's not even that.
A fighter jet does like 16 degrees.
Now they
And they said if you did that with an airliner, the passengers would be injured badly.
now they use the wings instead. So the wings they curve up the air. So
Oh, do they?
You don't even have to use so much of the air.
Yeah.
Going down.
So, anyways, not a realistic problem, but that's okay. Notice here, though, we were given an angle of 30 degrees below the horizontal. Okay, that obviously is not a direction angle. Okay, that's a description of an angle, which in the picture they actually translated for us. Okay. They showed us this 210 degree angle in standard position, okay? Notice coming from the positive x-axis, rotating counterclockwise, and we had 210 degrees. Okay?
Why do you have 210 degrees?
Because it's
Oh, 'cause
90,
they're added
180
30.
plus 30. So now, to find the magnitude of this vector, or not the magnitude, we know the magnitude is 100. To find this vector, we're going to take that 100 and we're going to multiply it by
Cosine of 210.
cosine of 210, sine of 210.
Should be.
Yeah.
Okay? And then, yeah, we know these from the unit circle. Cosine of 210 is negative
Root 3 over 2.
root 3 over 2. Because that's a 30 degree reference angle. Cosine's 3 over 2.
And negative 1/2.
And this one's going to be negative 1/2. Notice we're in the third quadrant, it makes sense that they're both negative. Okay. So now we multiply, and you can leave them in terms of the radical 3, so you'd have a negative 50 root 3 and negative 50. Or if you want to write it out as a decimal, that would be a negative 86.6 negative 50. Okay? And again, this isn't realistic because we're not going to be falling out of the sky at 50 miles an hour. Hopefully. At least it won't be very long. Anyways, Yash.
I don't understand why there's 100. Shouldn't it be? I don't understand.
Well, we want our magnitude to equal 100 miles per hour, right? So, this is just a unit vector that will get us going in the right direction. But its magnitude is 1 mile per hour. So to get it to be 100 miles per hour, I have to multiply it by 100.
So the unit vector is vector v over magnitude v, right?
Well, here, I get what you're saying. We're not dividing this time, or multiplying by the reciprocal, because we're making this vector to have a magnitude of 1 in the first place. That's where it's different from what the homework was. The homework, you were starting with vectors that didn't have a magnitude of 1 at the beginning, so you had to divide to get it equal to 1, then multiply by what you wanted it to be. Okay.
You know there's a magnitude of 1.
We know it has a magnitude of 1 because we used the cosine and sine,
Oh.
like our unit circle. Yes?
They're not always gonna have a picture, right?
Not always, no.
So if we didn't need a picture for this one, because if it's at 30 degrees below, like we would know. Just to
Yeah. Now, they would have to be a little bit more clear, because by saying 300 degrees below the horizontal, we don't know if it would be third or fourth quadrant. So they
Okay.
would have to say something like they were traveling west and
Okay.
descending or something like that.
But will they ever give you v and not the magnitude of v, and then you have to find the magnitude?
They could. They could say there were two planes and one had this vector and the other one went in the same direction but at this speed. So you'd have to find the direction of the first one and then get the second one. So, yeah, there's a lot of different possibilities. Now, one thing I did want to make sure we answered here is, what if the path of the plane had been given as a bearing? And of course, this one we wouldn't be looking at descending, but I just wanted to address this here at the beginning. You know, let's say instead of descending at an angle of 30 degrees, let's say we were going south of west by 30 degrees, okay? We're kind of looking from above instead of watching it land. All right, that one angle would have the 210 degree angle, okay? However, you might be given that same direction a few different ways. It may have told you that our bearing, which a bearing is measured from due north, clockwise, they might have told us that that was how many degrees?
240.
Okay?
250, sorry, my bad.
How much past south would we have gone? 60, right? So 180 and 60 would be 240.
Oh, you were right.
Or,
Why is it 240?
because we have 90, 180, and then to get over here to where there's 30 on this side, there'd be 60 over here, right?
Yes.
But-
Oh, why we start like, sorry, as north?
Well, because that, remember we did problems where you were given a bearing, okay? So the bearing is an angle from due north. Our formula requires us to use a direction angle.
So we would have done the cosine of 240 and the sine of 240.
No, you would have had to taken that and figured out what the direction angle was. that make sense?
That,
No.
what's it, what?
How do people
Okay, but didn't we find the direction angle of 210 in the other one?
Yeah, we did.
He's saying they
What
can
I'm
use
saying
two
is they
different
could have posed this whole problem differently. You would have to translate whatever angle they gave you. Like here, they could have told you that this was
Oh, so you would have had to
south 60 degrees west.
So you would have had to put him. So you always want to like put it in standard position before you do that. Then.
Yes.
Okay.
Okay. Let me get this. Okay. So, for example, if I was given, south 40 degrees east, the first thing that I would do is sketch that heading. Okay, south, here's east. Why I keep doing that? 40 degrees, that direction, 40 degrees. Okay, well, what would that be as a direction angle? Well, I would need to look at it as this angle right here.
310.
So 270 plus another 40. I would need to use 310 in that cosine of x, sine of x formula. Okay? Just whatever your angle you're given, draw it first and figure out what that direction angle will be. Okay?
So that's the heading, and then bearing's the opposite way.
Yeah, and they're actually used kind of interchangeably.
Yeah.
So you'll look at the context to see exactly which one you're going to use.
Are you gonna give us bearings on the quiz?
At this point, bearings should be. You should know what bearings are.
That's a yes.
Okay. All right. Here's another one in a different context, other than speeds, other than
I
velocities.
see a triangle.
We can use it as a force. Okay. Here we're pulling this boat and a trailer up a ramp, and the ramp is at 15 degrees. Okay? Well, if we want the weight, the combined weight of the boat and trailer, we're talking about the gravitational pull, right? That's what weight is.
Newtons, right?
No, that's force. Oh wait, would it be?
Yeah.
Yeah.
Meter,
It is
mass times acceleration.
Yeah.
No.
So
Physics.
in this case, which direction? Well, in all cases, which direction is gravity pulling?
Down.
Straight down. So if we're looking for a vector to describe the weight, what vector would we use of all these points?
Like
The y component of
BA.
Yeah, it's going to be a y, and like Thomas said, BA. Okay? BA is the vector that we're looking
I
at.
didn't even answer that question.
Okay?
So not me.
So there's BA. And then this vector right here, BC, that vector right there is the force that it's putting on the ramp directly. Okay? Because it's at an angle, alright? Now, we have a 15-degree angle right here. Okay? And then you have this vector right here, AC. If we're pulling the boat up the ramp,
You can say it's a right triangle.
yeah, we are going to say it's a right triangle. But if we're pulling this up the ramp, that vector AC is how much force it's taking to pull that up. So that 600 is right here.
That's the
600
magnitude.
pounds of force, yes. That's the magnitude. The direction, depending on how the direction would be 15 degrees up from the horizontal. Okay?
Wait, so AC is like the bottom part of like the picture?
Yes, right there.
I don't understand your triangle.
Yeah.
looks the same as,
Yeah.
I just sketched this triangle right here.
Did you make,
So did you just turn the triangle? Like the triangle they give us?
You turned it?
No, you're thinking of it in terms of, this is the weight straight down, which is what we're trying to find. This is pulling up the ramp, because it's parallel to the ramp, right?
what, C?
AC.
What about BC?
BC is how much pressure is actually being put on the ramp itself.
AC goes this way and
But
then
I'm
BC
confused
goes.
as to why you drew the little triangle under like the other triangle.
This right here?
Yeah.
Because as it is right here, the 15 degrees up from horizontal, we can't really tell a whole lot. We have to consider gravity. Gravity's going to push straight down. So then we're using this parallel, that parallel to the ramp. AC is parallel to the ramp. Okay?
I thought AC went this way.
It's true.
Oh, it does go that way. So then which one goes down? BC?
Down
It's
is
true.
BC is pushing down on the ramp itself.
And then
AB is gravity.
BA is gravity pushing it down. So like
BA, so how?
the full weight, when you're on a ramp, the ramp doesn't have to be able to hold your full weight. It's kind of like if you ever made a little bridge out of a 2x4 or something, you know, it was flat and it bended, you know,
Yeah.
just under your body weight. It would bend a lot because all of your weight was pushing it down. Whereas if you put it up on an angle, or if you put it straight up, it doesn't bend at all because the middle of it's not having to bear that weight.
I thought BC was gravity though because it's going straight down.
BC is not going straight down.
So then
BA is going straight down. See, BC is at an angle here,
How do you solve it?
perpendicular. When you have something sitting on the ramp, just listen. What the ramp actually has to endure is what's perpendicular to it. Okay? That's why I have this going down and it ends up perpendicular to the ramp, the 600 pounds that it's taking to pull up the ramp. Okay? So mathematically, if we want to figure out how much this thing weighs, we need to find the vector that's straight down. Alright? And someone already said, we'll use sine of that 15 degrees, and that's going to equal 600 over x.
And you just
And then you just solve for x. So how much does this thing end up weighing?
is sine of 15 degrees half of 1/4? Or is
No.
it that now?
No. Remember we had the double angle formulas and all that stuff? You'd have to use something like that.
Me.
Okay? What do we get? 600 divided by the sine of 15?
Sorry.
All of you have calculators. You're welcome to get them out yourselves.
What's called?
What?
What's the truth?
Hang on.
2000
4-0.
Are you in degrees?
No, divide. Don't multiply.
2,318. 0.22.
I am so
Okay.
confused. Because because it says 15, ramp incline 15 degrees up from the horizontal. So it's like
Yes.
that. Like that. But then how do you, like when you drew your triangle, like you just got to put the 15 degrees where you wanted it.
Well, no. These are similar triangles. Okay? These are going to be similar triangles.
Can you like redraw it so it's in the
I'm not
same
guilt
position?
tripping, I'm just confused.
Watch.
Oh,
Watch.
maybe.
Watch.
They gave you.
Part of it is you're overthinking a little bit, okay? 15 degrees right here. Gravity pushes straight down.
Yeah.
The boat pushes on the ramp at this angle. Quiet, please. Quiet, please. And we're pulling up the ramp like that. Okay? So gravity pushing against the ramp, pulling it up the ramp. Okay? That's how we figure it out. Okay? We'll do more. We'll practice. See ya.